A composite function is when the output of one function goes and becomes the input of another function. So we might have fx equals x squared and gx equals x plus 3. So in this case, if we're looking for f of gx, the output of gx goes and becomes the input of fx, so that we get something where x plus 3 squared is what we get. Alternatively, we can find g of fx, where the output of fx goes and becomes the input of gx. So what we get is x squared plus 3, like that. So that's example 1, and now let's try example 2, where hx equals x plus 5 and kx equals 1 over x plus 3. So if we're looking for h of kx, kx is the input that goes into hx. So what we get is 1 over x plus 3 that goes into x value plus 5. And alternatively, k over k of h of x is 1 over x plus 5 plus 3. Now let's have a look at the domain and range of g of fx. The first thing we do is to find the domain and range of what's on the inside, which is the f of x. The second thing we do is to find the domain and range of gx. A really important concept to remember here is that when we're looking at the fx and the gx, the output of the fx goes and becomes the input of the gx. This means that the y value of fx becomes the x value of gx. And so the range, which is associated with the y value, becomes the domain of gx. Now let's try an example where we have to find the g of fx, where fx equals 16 minus x squared and gx equals root x. The first thing we do is to find the domain and range of fx. So the domain is any real x. And the range is y is smaller than 16, because the maximum value that fx can be is when x equals 0, so fx equals 16. Step 2 is to think about the domain and range of gx. Remember what we talked about before. The y value, so the range of fx, goes and becomes the domain of gx. So since y is smaller than 16, x is also smaller or equal to 16. The next thing we need to do is look at the domain of gx itself. Looking at this, the domain must be greater or equal to 0. So we need to bring this back to the range of fx, where y must be greater or equal to 0 as well, and bring that back to find the domain, where 16 minus x squared must be greater or equal to 0, which gives us, according to finding inequalities, that x must be greater or equal to negative 4 and smaller or equal to 4. And so that's the domain that we have found. Looking at the range of fx, we have y is between 0 and 16. And looking at the domain of gx, we find that x must be between 0 and 16. And we also use this to find the range of gx, where after we sub that in, we find that y must be between 0 and 4. And so that's the range that we have found. So overall, the domain is that x must be greater or equal to negative 4 and smaller or equal to 4. And the range is that y must be greater or equal to 0 and must be smaller or equal to 4. So to summarize everything, we need to find the domain and range of the inside and the outside. The first thing we do is find the domain of fx, find the range, and then we use that to find the domain of what's on the outside, and then bring it back to the range of the inside, bring it back up to the domain of the inside, and then we use what we found about the outside of gx to find the range. So the domain of the overall function comes from the domain of what's on the inside, and the range comes from the range of what's on the outside.